Hello and welcome to HCI 509, Research Methods and Statistical Analysis. This is Lecture 2 on Research Hypotheses. Let's get started. First, I want to talk about the different types of behavioral research. In a broad way, most HCI investigation methods could be categorized into one of three different types. There's descriptive, relational, and also experimental. So let's take a look at each one of them in turn. First, descriptive investigations, they focus on constructing an accurate description of what's happening. So these can include methods like observations, surveys, and focus groups. So for example, a researcher observes that 8 out of 10 teenagers in a class frequently play a specific computer game and they can touch type, while only 2 out of 12 in the same class who don't play that game touch type. So that raises an important question. It doesn't allow us to establish a relationship between the two factors, playing the game and typing. It also doesn't enable the research to a researcher to explain why this is happening. It's really just a description of an observation. There's no real cause of the relationship between the two factors. It's really unknown. It's just you see two things happen, and this is something that we can describe. A correlation analysis between the number of hours and the typing speed. And if that result is significant, it can suggest that there's a relationship between the two factors. So results of relational studies will usually carry more weight. The second type of investigation is relational investigations. And these enable a researcher to identify relations between multiple factors. So if the value of a factor X changes as the value of factor Y changes, this is a relation between the two factors. So a more concrete example might be a researcher collecting data on the number of hours that teenagers play games per week and then measuring their typing speed. So the researcher can run a correlation analysis between the number of hours and the typing speed. And if the result is significant, it can suggest that there's a relationship between the two factors. These types of relational studies usually carry more weight than the first one we looked at, which is descriptive study. However, they don't show a causal relationship between multiple factors. And that's where the third type of investigation comes in. However, before we look at the third one, let's take a look at some of the pitfalls of correlations. Before we look at that, we need to talk about some of the pitfalls of correlations. So a significant correlation result does not allow the researcher to determine the cause of the observed relationship. So it's possible that playing the game improves the typing speed, but it's also possible that the type of teenagers who type well tend to like to play the game more and spend more time in the game. So you could have the aggregate result that the correlation could be due to other factors, we call them hidden factors, that the researcher hasn't even considered or studied. So this goes back to what I'm mentioning in the previous lecture about context. The facts are important so that if you find this case, a correlation, it may not be true, or it might be due to other factors that are unrelated to what you're considering. So maybe teenagers who read well tend to type faster. And the teenagers who read well tend to like to play games more, and they spend more time on gaming. In this case, the computer game has no impact on the typing speed of the teenagers, but we found a correlation. There's actually a website called Spurious Correlations. It shows absurd correlations and how easy it is to make correlations between two things that are not even remotely related. It's kind of a fun way to look at correlations and think about data. It's not really implying causation or meant to create distrust in research or even correlative data right. That's just really showing something that can happen, not something that always happens. The website's goal is really to foster interest in statistics and numerical research. So here's an example that shows a correlation between the red line here is the graph of the number of people who have drowned by falling in a pool, and the black line represents the films that Nicolas Cage appeared in per year. So you can see here, there's a pretty tight correlation, 66%, almost a 2/3 correlation. It looks like these things are very well correlated, but really it's just an observed example. Really, these types of examples show kind of the danger of assuming that one is related to the other when all they are is correlated. The last type of investigations are experimental investigations. Now, these allow us to look at the causal effect between two factors. So, for example, researchers will recruit teenagers in the same age group to randomly assign them to two groups. One will spend a certain amount of time playing games each week, and the other will not. And after a specified period of time, say 3 months, researchers measure each teenager's typing speed. So if the teenagers who play the game well type significantly faster than the teenagers who don't play the game, then the researchers can draw the conclusion that playing the game or games improves the typing skills of teenagers. And I highlight the word significantly because that's the next topic of our next lecture, which is significance tests. So keep in mind that significance is important. Here's a summary of the different types of investigations that we've seen. So really, we have descriptive, relational, and experimental. And as we go down, the strength of or the power of showing evidence is much stronger. So the descriptive says a general claim that X is happening, whereas the relational finds that the relationship between X and Y, and experimental can claim that X is responsible for Y. So it's a causal relationship. And here's some of the typical methods for each of these observations. So a descriptive will have observation, field studies, focus groups, interviews. Relation will have observations, field studies, and surveys. And experimental is usually controlled experiments. Now, the three types of research methods are not totally independent, but they're highly interdependent. So actually, typical research projects will include a combination of two or maybe three types of investigation. So there you go. Let's go and talk about the main purpose of this lecture, which is research hypotheses. So a research experiment will normally start with the research hypothesis. And a research hypothesis is a precise, notice the underlining, problem statement that can be directly tested through empirical investigation. Compared with a theory, a hypothesis is a smaller, much more focused statement that can be examined with usually a single experiment. A concrete research hypothesis will lay the foundation of an experiment as well as the basis of the statistical significance testing. So before you even start thinking about statistics and how to analyze your data, the first thing you should know at the end, like I said at the last lecture, is what is your research problem, and state this problem in a precise way so you know exactly what you're measuring. And this is more challenging than it may seem, because following the lectures is one thing, but when it comes down to setting up a research plan, a research problem, it can be a challenge. So we need to do that there's a couple of steps, and we'll learn those here in terms of how to write good research statements and hypotheses. So everything starts with a hypothesis. So one important thing to realize is you have a null and an alternative hypothesis. You always have at least one null and one alternative hypothesis. So the null hypothesis is typically the more conservative or status quo. It states that there's no significant difference between, say, two experimental treatments. Whereas the alternative hypothesis is always saying that there's something that impacts the performance or whatever you're measuring. And the alternative hypothesis is something that's mutually exclusive. In other words, the null and alternative hypotheses can't both be true. So how the alternative hypothesis is written is important. So here's an example. So here's an example of a hypothesis. The developers of a website are trying to figure out whether to use a pull-down or a pop-up menu in the home page. So they decide to conduct an experiment to find out which menu design allows the users to navigate more effectively. So the null hypothesis here will be that there's no, notice the H sub 0, there's no significant difference between the pull down and the pop-up menus in the time spent locating pages. Whereas the alternative hypothesis says there's a significant difference between the pull down and pop-up menus in the time spent locating pages. So you can see here that they're both well written and in a mutually exclusive way. So you can see that only thing is different is the beginning. So what we have for the null is there's no significant difference, and for the alternative or H1, there is a significant difference. So you can see here that both of those can't be true at the same time. They're mutually exclusive. So when you have an experiment, the goal of your experiment is to test the null hypothesis against the alternative hypothesis and decide which one should be accepted and which one should be rejected. So the experiment should find statistical evidence to support your hypothesis. And the result of any significance test will tell us whether it's reasonable to reject a null hypothesis and what the likelihood of it being wrong. And we'll look more at this in our next lecture. It is possible to have multiple pairs of hypotheses. Actually, there's no limit to the number of hypotheses that you can have investigated in one experiment. However, it's generally recommended that you don't attempt too many in a single experiment because the more hypotheses you're testing, the more factors need to be controlled, which is a challenge, and measured, and there's more room for error. And with so many different things to keep control over, it results in a very complicated experiment. So it's subject to a high risk of design flaws, and the errors could be at the root of everything in your experimental design. So you have to be very careful what you're doing. Several pairs of hypotheses for your experiment might look like the following. So aside from time spent locating pages, researchers may study the following additional. So here's our null hypothesis. There's no significant difference in user satisfaction between the pull down and the pop-up menus. So the first alternative is there is a significant difference in the user satisfaction rating between the pull down and the pop-up menus. So here you could see that we are not only studying the time spent locating pages, but we're also looking at user satisfaction. So in one experiment, we're looking at two different dependent variables. We'll talk about that in a minute. So there's some criteria for defining what is a good hypothesis. The first is the hypothesis should be presented in a precise, lucid language. And the second is that the hypothesis should be focused on a problem that's testable, verifiable, in a single experiment. A highlighted word here is testable, because that means that a hypothesis shouldn't be so broad and abstract. It should be something that's very clear in terms of what we're trying to measure. The third criteria is that it should clearly state the control groups of the conditions of the experiment. So when you're in the early stages of an experiment or a project, you usually find yourself confronted with a very broad and vague task. You don't necessarily always know or what the exact research question is. So in this case, there's no focused testable research hypotheses. You could, for example, conduct an exploratory descriptive investigation like an observation or interview or a focus group to help you identify what the key research issues are. And then you can start working on finding relationships or formulating an experiment to find causes. The last major topic of this lecture are variables. Now, variables are an important part of hypothesis testing, and you'll see why. First, what you have to know is the difference between independent and dependent variables. Independent variables are the factors that the researchers are trying to study. So what are the possible causes of the change? The dependent variable is the one that is the outcome or effect. So you could perform a test. Dependent variable is what is dependent on the factors that you are changing or varying in your study. So in this case, it might be on your performance. So that performance is dependent on what the independent variables are that we chose. So we use the word dependent because it's dependent on the participant's behavior or certain factors in the independent variable. So let's take a look at an example here. So the null hypothesis is there's no significant difference between the pull down and the pop-up menus in the time spent locating pages. The independent variable here is the type of menu. So we have two choices, pull down or pop up. And then when we're doing the experiment, we have full control over the types of menu which each participant interacts. The dependent variable is the time spent locating web pages, right? So that's what we're trying to determine as our output. And this outcome is our dependent variable. So time is dependent on what we have chosen for our independent variable, which is the pop-up or the pull-down menus. So the time that the participant or subject uses to do the task is not something that the researchers can fully control. It's really dependent on the subject's performance based on the independent variable. So let's take a look at some typical independent variables in HCI. It can be different for different types of technology or devices, like typing versus speech-based dictation, mouse versus joystick, and it can be different types of design. So for example, pull down versus pop-up, which we talked about, font sizes, contrast, background. It could be using music or not. It could be user-related, such as demographics, and these include things like computer experiment, also looking at, for example, the time of day that they're taking the test, and other factors like this. It could be context related, such as environmental factors, or the number of people. Is it a noisy room, or are they taking this experiment in a controlled setting where there's limited interruptions? So let's take a look at some typical dependent variables. So one might be efficiency. And again, it helps to define how you're calculating efficiency, because efficiency can be defined many different ways. So it might be the time to complete a task. It might be the speed, words per minute. Now, efficiency also could look at the number of errors that you make. Accuracy kind of ties into this. The accuracy also needs to be defined because there's many different ways to calculate accuracy. So it might be the error rate, which is a rate, so it's a percentage. There is usually a trade-off between efficiency and accuracy. So think about typing. The faster you type, the less chance you are to be accurate. And if you type slowly, your chances of being accurate are more. However, this is just a general observation. So we just have to realize that these might be two things, these two dependent variables that might be interested to be looked at for a particular task in HCI. So you want to make sure that if you're looking at accuracy, you consider efficiency as well. Another one might be subjective satisfaction, which is the user's perceived satisfaction with the overall experience. So we typically might use a Likert scale. That's the one where you have a bunch of bubbles, 1 through 5, and you have discrete values. The ease of learning, or the retention rate, so how quickly, meaning how little time does it take for somebody to reach a certain level of accuracy. What is the retention rate? How are they able to retain the information over a specified period of time? It could be physical or cognitive demand, such as a description of the demands and how long an individual can execute the task without undergoing significant fatigue. So that covers research hypothesis. I hope you enjoyed this lecture, and I'll see you on the next one.